Okay, this is section 5.3, excuse me, modeling data with power functions. It just comes down to finding where is the power function regression in the second calc stat menu. So, modeling data with power functions. Okay, now, while there is a way to determine if data will exactly or approximately fit a power function when the power is a whole number, we'll postpone giving that until section 5.5, where it's more appropriate to do so. Okay, 5.5 looks at what are called polynomial models, which is a generalization of some of the power functions. So when modeling data using a power function, we'll of course use the power regression feature of our calculator. It's found in Stat Calc, and it's choice A, power regression. Of course, we're going to have to give the data in list 1 for the independent variable and L2 for the dependent variable. Again, assuming your calculator still has list 1 and list 2. If it doesn't, you may have to just reset your calculator or remember what list you're using for X and Y. Now, warning, the calculator cannot deal with values of 0 in either the independent variable or the dependent variable. I've misspelled dependent, haven't I? So, remember, no zeros for either X or Y. You'll get an error statement. It just won't be able to do it. So, some examples. Okay, number 1 says, find a power model for the data below and graph the data and the model in an appropriate viewing window. Round all parameters to 3 places to the right of the decimal point. So let's go ahead and set up our calculator here. Let's see, turn it on. Let's set our mode float to 3. So float on over to 3, enter. Okay, we can probably figure out a nice viewing window right now. So window. Okay. Now, even though the power model won't allow 0, I'm going to still have my x-min to be 0. Okay, it only goes out to 10, so there are multiples of, increments of 2. So let me go out to 12 and have the scale be 2. Okay, again, I'm going to let my y-min be 0. The largest one appears to be 430. Let me go out to 500. What the heck? Let's be bold and daring. 500. Whoops, I said 500, but I did 50. 500. And the scale, I don't know, maybe multiples of 50. That way I'll have 10 tick marks. Okay, so I've got my window set up. So let me quit that. Well, let me get caught up here. Then we have to enter the data. So enter the data into the calculator. So got something that looks like that. So let's see, stat, enter. Okay, let's go back to L2. 2, 4, 6, 8, 10. Okay, then 10, 51, 130. 255, 430, enter. Okay, then of course we would quit the screen, quit. So then step 2, you're going to do your stat calc, and again it's a power regression. So I'm going to store my equation in L1, and then where we calculate and everything. So let's see. So stat calc choice alpha A. Okay, my list 1, list 2 is fine. Regression, bars, y bars, function, enter, sure. Calculate, there we go. So I have 1.988 times x raised to the 2.335 power. Now here, remember, I didn't set my float. And then there's the graph. Okay, there's my window. Okay, it's the same that I had before, so just to make life complete. Graph. Oh, I didn't turn my stat plot on, did I here? That's why I don't have any dots. So let me let it finish drawing. So second stat plot, turn on number 1. And graph again. And the model looks pretty doggone good, doesn't it? Okay, example number 2. According to American General Life Insurance Company, The table below gives the monthly insurance rates for a $100,000 life insurance policy for smokers from the ages of 41 to 49. So there it is. Question A. Find a power model y equal f of x for the data where x equals age and y equals insurance rate. Round all parameters 3 place regarding the decimal point. In question B, based on the model, what happens to the insurance rate if the age increases by 50%? Round your final answer to 2 places to the right of the decimal point. Okay, let me get our calculator set up to do all this. So my y equals, let me clear them out, clear, oh, it was only one. And then let's see my lists. So second, memory, choice 4. Okay, my lists are clear. So I guess first of all I'm going to have to enter the data. And notice it's not going to ask me to graph anything, right? So, and I don't really need to store it in Y1. So let me just go ahead and start entering the data. So, stat, edit, okay, the L1 is going 41 to 49, so 41, enter, 42, enter, 43, enter, 44, enter, 45, enter, 46, enter, 47, enter, 48, enter, 49, enter. And I've kept my float to 3, so I'm good. Okay, and then what was it for 41? What did I have? Okay, $21. Okay, and then 22.22. Wait for it to go. 22.22, enter, 23.71. Now, of course, the money is also showing that extra decimal place because of my float. 25.11, 26.60, 28, 29.40, 30.80, and 32.55. Enter. Okay. So again, our solutions. Okay. After entering the data and everything, I got all this. So let me do second, quit, stat, calc. And it was choice A, did we say? That A. Power, yes. Don't need to store it. Oh, I gotta scroll down to calculate, don't I? So there. 0.002 times x raised to the 2.450 power. Okay. Okay, our power is 2.450. Now that's going to become important for question B. Okay, question B, an increase of 50% in age factor is an age, again, is a factor of 1.5, right? 100% plus 50%. So I'm multiplying the x values by 1.5. So remember, according to the homogeneity property, the rate will increase by a factor of 1.5 times, raised to the 2.450 power, which is about 2.70 to the nearest hundredth. So rates will increase by a factor of 2.70. Now, because we've done this regression so much in the past, we really don't need to do a whole lot of examples of this, so that's the end of section 5.3.